Hi guys, this one I couldn't for some reason access it on my iPad, so I couldn't screenshot it, but this is number 5 on chapter 6, homework number 1, labeled specific heat. So this states a volume of 110 milliliters of H2O is initially at room temperature, 22 degrees Celsius. A chilled steel rod at 2 degrees Celsius is placed in the water. If the final temperature of the system is 21.3 degrees Celsius, what is the mass of the steel bar? Now what this is you remember, oh, that's a bad choice. We'll try this one. Q equals mass multiplied by specific heat multiplied by delta T. Mass grams, specific heat, delta T is the change in temperature. So we have to combine these. So the formula in the book will be like this: minus M1 multiplied by specific heat multiplied by delta T equals M2 multiplied by specific heat multiplied by delta T. Now this negative here, people were asking during class, is there to make it so we can have a positive value for the M2, or whatever mass we're trying to solve for. So just make sure you don't forget about that M, because it's important to stay there. 1 second. Alright, let's get back to this. So, what do we know, what don't we know? We know the mass of object 1, because right here it says 110 milliliters. Now 1 milliliter equals 1 gram. So, we can fill that in a little bit. We know we have, back right there. Apologize, sorry. So we know we have the mass of M1. We can check that off. We know we have the specific heat of water. Check that off. We know we have the change in temperature. We know we have the change in temperature for steel, specific heat for steel, but we do not have the M2, the mass of the steel, and that is what we were asked to solve for. Now, before you even do anything now, I like to solve for this algebraically without numerical values in it first. So what do? How do you do that? We know we have to solve for M2, so you should get something like this. Minus M1 multiplied by specific heat multiplied by the change in T divided by specific heat of, we'll say steel, multiplied by the delta T of steel equals M2. So now we just plug in stuff that we are given. We know that mass 1 would be this, minus 110 multiplied by the specific heat of 4.18 multiplied by the change in temperature. Now some people may think that the change in temperature will be the equivalent for both of them, but they're not. Remember that the top is for water, so we see it's initially at 22 degrees, and it gets final system of 21.3, and we remember that delta T equals T final minus T initial, right? So the T final of water was 21.30 subtracted from 22.0. Oh, let me erase that. That was a bad line. Alright, let's get back to this. Specific heat of steel would be 0.452 multiplied by the change in temperature of steel. Remember, it's not the same as the other one, so it's going to be something like this. Let's read the problem. A chilled steel rod at 2 degrees Celsius, that's the initial, and it has a final temperature of the system of 21.3, so that's 21.3 minus 2. And what does this value equal? Well, when you plug this into your calculator, I got roughly 36.9 grams. So M2 equals 36.9 grams. Now, there's one more part of this problem. We're going to go to the next page to solve for it. Alright, so the problem is asking us to find the molar heat capacity of water. And specific heat heat of water of H2O equals 4.18. Now remember we have to include the units. We have 4.18 joules over grams multiplied by degrees Celsius. And it's asking us to solve for the molar heat capacity. Molar heat capacity has the units of joules per moles times Celsius. So now we just have some dimension analysis. We have 4.18, so let's solve for it. We have 4.18 joules per gram times degrees Celsius multiplied by what over what? We want moles down here, but we have grams down here right now, so we have to get 1 mole down here. And how many grams is in 1 mole? Well, I got around 18.02. So now you just multiply this out. 18.02 times 4.18. What happens is the grams cancel out, so now you get a value of 75.2 joules per mole times degrees Celsius. And that is it. This next problem states it takes 53.0 joules to raise the temperature of a 9.9 gram piece of unknown metal from 13 degrees to 24.6 degrees Celsius. Find the specific heat. I wasn't able to copy this one down, but we can just write this out. Specific heat formula to solve for it is Q equals mass times specific heat times delta T. This formula isn't specifically going to give you the specific heat in this order, but specific heat is located in here, so we know we can solve doing some basic algebra to solve for it. Let's do that out. If we just want to solve for CS, we should get something that's CS equals Q divided by mass multiplied by delta T, right? Perfect. So the problem told us that we have a 9.90 grams of an unknown metal, and the temperature change was 24.6 minus 13, and the energy was 53.0 joules. Now this one is number 6 on homework chapter, number 6 on chapter 6, homework number 1. So we just plug in things that we know and we don't know. So we know that CS is going to equal 53 divided by mass, which is 9.9, multiplied by 24.6 minus 13. Remember, 24 is the final, 13 was the initial. So when you get this in your calculator, you should get a value of roughly 0.462. But obviously there's no units here, so this value is correct. Let's just push this down over here. 0.462 joules per gram times Celsius. And that is the value.